The Neoliner Origin was designed to rethink maritime transport through performance, efficiency, and reduced emissions. On board a vessel carrying cargo, passengers, and vehicles, including electric vehicles, fire safety is not an add-on, but a core element of the ship's design.
My name is Guilhem Péan, and I am the Neoline's technical director. Neoliner Origin is a roll-on roll-off vessel, primarily sail-powered. So, the cargoes enter in the ship by rolling on and exit by rolling off. We anticipate an 80% reduction in polluting emissions. The first shipment on the Neoliner Origin was about 300 cars, most of which were electric.
For the Neoline teams, fire safety is a daily concern, shaped by hands-on experience and their background as seafarers.
Like all ship owners, and as former sailors, we, the project leaders, fire safety is vital for us on board. It's a daily concern for all sailors on board ships. So when we get the chance to move from being sailors to ship owners, and thus to ship design, it's a topic that comes up very quickly, and one to which we pay a great deal of attention.
Instead of combining multiple systems, the Neoline team looked for one consistent approach capable of protecting different risks across the vessel.
We are obligated to protect the engine room, the cargo spaces, and the living quarters. And so for each of these areas, we have different options available to us. In the engine room, we opted for the water mist system as our preferred solution to protect the sailors. Carbon dioxide in the engine room is always extremely dangerous for an engineering officer. If a mechanic is injured in an engine room, we need to be able to activate the fixed suppression system and retrieve the injured. Regarding these arrangements, the water mist system, while not mandatory for a RoRo cargo vessel, is an additional comfort and a supplementary safety measure for the crew, which is truly undeniable.
In cargo spaces, fire protection systems must meet multiple challenges simultaneously. They must be highly effective, protect crew and passengers, minimize both water and energy demand, and remain compatible with seawater use without clogging risks.
In the cargo areas, we were presented with a challenge regarding the ability to charge electric vehicles. So, this is a challenge that all RoRo vessels are currently facing, and there is currently no solution officially recommended at the regulatory level. So, the approach was to look at everything that was being done and what seemed to be most effective against battery fires. For garages, for cargo compartments, we opted for a drencher and a low-pressure system instead of CO2, for the same reasons regarding CO2's danger, and also due to space constraints on board. Since the CO2 we must store on board requires an enormous amount of space, plus annual maintenance of the CO2 system, which is both time-consuming and costly. Low pressure also allows for less water consumption and in more confined spaces. It's less expensive to invest in a low-pressure system than a high-pressure system. Therefore, for all these reasons, considering the identified risks, the VID Firekill solution appeared to us to be the best option available on the market.
For a vessel built around efficiency and wind propulsion, the fire protection system had to follow the same philosophy. The VID Firekill low-pressure water mist technology reduces water and energy consumption, minimizes system footprint and weight, and enhances safety on board. The system has been fully tested in accordance with the latest IMO regulations. In addition, independent car deck fire tests involving electric vehicles were successfully conducted as part of the Elbus project, a technology designed to support the evolution of maritime transport while keeping safety uncompromised. Built for efficiency, designed for safety, engineered by VID Firekill.